There's one last big idea that we've skated past, and I'm going to introduce this with a hypothetical. Suppose that Greg and his friend Jeff Adams are both walking down the street, and a student recognizes them. And that student drops a couple of flower pots from the second-story window, and those flower pots hit Greg and Jeff going 20 meters per second. Now, in the case of Jeff, that flower pot bounces off his head at 20 meters per second. In the case of Greg, it stops. Now the question is, if the delta t for that collision is the same for both Greg and Jeff, who has the worst headache? Who had the biggest force applied to their head? Talk to your neighbor. Which is it? Greg or Jeff are the same? Okay, let's vote with our hands. Those who say Greg has the bigger headache. Those who say Jeff has the bigger headache. Those who aren't sure. Okay. The reason we divided the class like that, suggesting there's confusion, is because I lied to you. I told you over and over again that momentum was mass times speed. That's a lie. Momentum is a vector, and it's mass times velocity, and the direction is critical. It's critical. If I have a baseball coming in at 50 miles an hour, it's hit by a bat and it goes off at 50 miles an hour, that seems like the same momentum. Mass times 50 miles an hour. But in one case it's going east, and in the other case it's going west. Those are very, very different momenta. And if I want to know how different they are, I do what I always do. I take those two vectors and I put them tail to tail. And I ask myself, what would I have to add to this vector to turn it into that vector? Well, I would have to add this. There's the plus sign right there. This change in momentum takes the initial momentum, brings it down to 0, and out the other way. Now that change in momentum is caused by the impulse, which is the force times the time. Now if we go back to my example, in the case of Jeff, that flower pot bounces. And that means the change in momentum is twice the magnitude of the initial momentum. If I look at the case of Greg, it stops. And that means the change in momentum is the same magnitude as the initial momentum. Jeff's head not only has to stop the flower pot, it has to stop it and throw it back up in the air. That is a much greater force required if the time is the same. And if Jeff is putting a much greater force on the pot is putting a much greater force on the Jeff. Now I have to tell you, many years ago, Jeff and I were going to our cars out there in the parking lot, crossing Grant Street on a very, very icy February afternoon. And as we were crossing the street, this great big huge older car just came, it slammed on its brake, couldn't stop, it just came racing through the intersection. Jeff and I both turned around, put our hands on the hood, and it pushed us right through that intersection and down Grant Street. I'm terrified. I look over and Jeff is just smiling, and he says to me, "Is this one of your students or one of mine?" Folks, that's all I had prepared today. We went a little faster than normal. So why don't you just take the rest of the time off and get yourself a donut.